I am Dr. Binu. In digital signal processing subject, the fourth unit is finite word length effects. It consists of fixed point and floating point number representation, analog to digital conversion, quantization, truncation and rounding, quantization noise, the types of varieties of quantization noise as well as errors, limit cycle oscillations due to product quantization and summation, then scaling to prevent overflow. The first topic is fixed point and floating point number representation. What is meant by fixed point representation? It is a method of storing real numbers in a computer system where the position of the decimal or binary point is fixed. This method divides the number into integer part as well as fractional part. The split is determined by the number of bits allocated for each. The binary point remains in the same position. It consists of unsigned fixed point and signed fixed point. The unsigned fixed point consists of integer as well as fractional part only. The signed fixed point consists of one bit is assigned for signed bit, the remaining bits for integer as well as fractional part. The uses of fixed point representations are: it can be applied in digital signal processing, embedded systems, financial calculations, hardware design, and real-time systems. How the unsigned fixed point is represented. For example, 8,3 in fixed point representation means here 8 bit is the fixed point number, the rightmost 3 bits of which are fraction. How we can represent a real number? For the binary value 00010.1102 means here the 110 is the fractional part, remaining of fixed number. Signed representation. Negative integers in binary number systems must be encoded using signed number representation. In mathematics, negative numbers are represented by this simple minus sign before them. But in computer hardware, here we are not having an additional symbol. So in order to represent the negative, we have to assign one particular bit for sign. In signed representation, signed binary numbers may be positive or negative, can be represented in one of three ways: sign magnitude form, 1's complement form, and 2's complement form. What is meant by sign magnitude form? In sign magnitude form, the number's sign is represented by the MSB, that is most significant bit, as well as least significant bit. Most significant bit is the leftmost bit. In case 8-bit representation means leftmost bit is the sign bit and the remaining bits are magnitude bits. In 1's complement form, by complementing each bit in a signed binary integer, the 1's complement of a number can be derived. A result is a negative number when a positive number is complemented by 1. Similar to this, complementing a negative number by 1 results in positive number. For example, if the 55 is the decimal number, means if we are taking 1's complement to the 55 in a decimal number, it becomes minus 55. 2's complement form, by adding 1 to the signed binary numbers, 1's complement, a binary number can be converted to its 2's complement. Therefore, if positive numbers 2's complement result in a negative number, the complement of a negative number by 2 yields a positive number. Fixed point representation of negative number. Consider a number minus 2.5 fixed w, p with the 4 binary point 1 bit. How the number is represented in fixed point means is represented in this manner. 1's complement representation 127, 1's complement value is 1000, then 128, so 1's complement is 011. The 1's complement range is minus 127 to 127. Then we will see what is meant by 2's complement representation with some example. 1 bit in 2's complement number is effectively used as a sign bit, leaving you only 7 bits to the actual number in an 8-bit integer. So the 2's complement range is minus 128 to 127. Floating point representation. The floating point representation is a way to encode numbers in a format that can handle very large and very small values. It is based on scientific notation where numbers are represented as a fraction and an exponent. In computing, this representation allows for a trade-off between range and precision. The format for floating point representation is typically represented as significant, base, and exponent. Here the sign bit indicates whether the number is positive or negative. Significant is also called as mantissa, which represents the precision bits of the number. Base, usually 2 in binary system. Exponent determines the scale of the number. What is the need for floating point representation? It can be normally used for range, and it can be represent a wide range of values from very large to very small numbers. Second need is for precision. It provides good balance between the precision and range, making it suitable for scientific computations, graphics, and other applications where exact values and wide ranges are necessary. Third need is flexibility. It adapts to different scales of numbers, allowing for the efficient storage and computation of real numbers in the computer system. Number system and data representation. Number system, the floating point representation often uses binary systems for the digital computers. Other number systems like decimal, hexadecimal may also be used in different contexts. Data representation. This includes how numbers are stored in the computer memory involving binary encoding and representation of the various data types. This table represents the precision representation. The precision is represented in single precision as well as double precision. In single precision, the base value is 2, sign value is 1, exponent is 8, significant is 23 plus 1. In double precision means the base sign is common as that of single precision, but the exponent is 11, significant is 52 plus 1. What are the various components of floating point numbers? Sign bit, exponent, as well as mantissa, which is also called a significant. This slide shows the differences between fixed point and floating point representation. In fixed point is a fixed decimal number. Here, flexible decimal range. It is normally used for simple computation. In floating point is normally used for complex computation. This table differentiates the floating point arithmetic and fixed point arithmetics with various parameters like hardware requirement, handling and code readability, numerical stability, and testability. This table represents the fixed point as well as floating point number representation in the singular differences. That is, it is a representation of real data type for a number that has fixed number of digits after the reference point. But in a floating point, its real numbers as an approximation to support the trade-off between range and precision. Fixed point are having higher performance, floating are having lower performance. Less flexible if it is in the fixed point, more flexible in the floating point.